Hi, I'm Maayan. Welcome to my talk, Devfirst Open Source Data Observability, Why and How We Built It. So first, about myself, I'm from Tel Aviv. I like football, the one you actually play with your foot, and my dog, which you can see here in the picture. And I'm the CEO of Elementry-Data. Elementary is an open source data observability solution for data and analytics engineers. You can use it to monitor your data and monitor your operations. But I'm not here to talk a lot about the product, but more on why and how we built it. So why data observability and why Devfirst? When my co-founder and I decided to build Elementary, we wanted to solve a problem that we experienced firsthand. And everyone who ever worked with data know how frustrating observability can be. Basically, things break and you have no idea what and why. And we also wanted to build a solution that we would have wanted to use. And as developers, it meant to build a solution that is very dev-first, integrated with what we already use and know. So more on that later. At that point, we were just going through Y Combinator. So you can see here two very dominant orange logos from our story. And we went and talked to users because that's what you do in Y Combinator. And we kept hearing how users are using DBT and how data teams are leveraging it. And we decided that this would be the segment we're going to focus on. Developers building DBT projects, basically analytics engineers, and we're going to build an observability solution for them. What does it mean to build observability for data teams? So data observability is usually defined as freshness, volume, schema, quality metrics, and lineage. But we thought that for DBT users, and also what we heard from them was that something else is missing as well. And you can see that DBT users talk a lot about the need of operations observability, and not just observing the data, but also knowing exactly what's going on in your jobs and invocations and what are the results. So in Elementary, we decided to build both operations observability and data observability. But what does it mean to build it dev first? So we wanted the lowest possible friction deployment, meaning only using the skill set and the tools you already know and have, using your existing stack and your existing workflows. How we actually implemented it? The deployment is done through a DBT package and a CLI. A DBT package is just code you import into your DBT project. And if you're a DBT user, you're probably familiar with working with a CLI. And we depend only on your existing stack, your DBT project, orchestrator, and data warehouse. This is how it works. Basically, the Elementary DBT package creates a schema in your data warehouse as part of your DBT project. You don't need to run any special command. Any DBT test or DBT run invocation enriches that schema with more data. And then you can use our CLI. The CLI reads from the Elementary schema and generates a UI. You can host that UI using S3 or GCS or just send it to Slack. And the CLI also generates Slack alerts, which you can send and distribute into different channels and users. But what does it mean to build into the existing workflows? So we came up with a concept called DBT Native. All of our configuration and features we try to make them as DBT native as possible. And I'm going to give just 3 examples so you'll get the sense of it. Here are the 3 examples: DBT logs and metadata, anomaly detection as DBT test, and Slack alert configuration. Let's go into each one. So some of you might be familiar with DBT artifacts. DBT artifacts are JSON files, which are created on each of your DBT invocations. They contain the results of your runs. You can call them the logs of your project, and all of your metadata. What are your models? What are your tests? All the configuration the project has. At first, we thought we would need to build an external solution, taking the JSON files, parse them, upload them somewhere, maybe run them using Airflow. But what does it mean to build a DBT native solution? We were able to take all of that info from the DBT code during the runs from Python objects they reveal and write as part of the runs and the invocations, whether DBT package, to parse all that data and load it into tables in the user's data warehouse. So basically our users get a DBT native solution. All of their logs are uploaded into their data warehouse to different tables. Data anomaly detection as DBT tests. We wanted to add the ability to detect anomalies in your data, which is a crucial part of data observability. And we didn't want to introduce a new technology. We wanted to use the building blocks that our users already know. So we implemented new kind of DBT tests, which are stateful and actually collect data over time. As you can see on the left, you can configure them just like you configure any other DBT test. You call them elementary table anomalies in this case, which monitor for row count and freshness. And on the right, you can see from our UI how a result of such a test looks and how a failure looks like. And on the bottom, you can see that this is a regular DBT test. You execute it, you can see its failure right as part of your normal failures. And you can also use our UI to visualize the results in kind of a more informative way. But these are DBT tests, and you can use them just like you use any other test in your stack. And lastly, we have our Slack alerts configuration. You can use our Slack alerts to alert on failures in models, failures in tests, warnings of all kinds. And also with our Slack alerts, we wanted to make them as DBT native as possible. So all of the configuration is done straight in your YAML files. You can see here, you can define a specific channel, a specific owner, specific tags, and all of that data is used directly to generate our Slack alerts. If you put an owner that is a Slack user, it gets tagged and everything. So this is what it means to build a Devfirst open source data observability solution. And I would love you to try it yourself. This is a link to our repo. Everything is 100% open source. We're like working and building with our users, collaborating with them on different features. We're very active on our own Slack community, and we invite you to join and try it and give us as much feedback as possible. Thank you.